So last video we stopped here, that is need for image retrieval, and I was talking about when you tag the images, you have to manually tag the images, and even if you tag something like synonyms, you will not find that particular image because that tag will not be present. So if you say ki I want photos of tea, but somebody may tag it at chai, so those images will not come. And there is problem of mistag. You can see this is not Rihanna, somebody has tagged a wrong lady as Rihanna, and your search image is showing first image. So person who don't know Rihanna and want to know about how she looks like, he might be misleaded with the tags. So describing every image is not possible, as well as the synonyms will not be matched. Another motivation is, here is the graph where you can see the number of images uploaded per year is growing exponentially, and the number is in millions. So 600 millions, it is not possible for a human being to tag 600 millions photos, and even social media networks like Facebook, and it's for only 3 sites, and it could be there are lakhs of other sites. So you can multiply that number by this number, and you can see the number of images is practically impossible. And another thing is, graph is growing exponentially. So even it is possible for, let's say, next 10 years, after that it will become impossible to tag each and every image. And there are some facilities such as extension tagging, geo tagging, where you click the photo, that tag is automatically attached by GPS system. But that is also not foolproof, because your camera may not be in the GPS range every time, or there could be other issues. So the tagging to every image in the world is practically impossible, and that's where the motivation comes for the content based image retrieval rather than the tag search or conventional image retrieval system. So in this system you give one input query image, and from the large database it will extract the retrieved image in a ranked fashion. So it will not say ki this is the correct image or this is the correct image. It will say ki these are the possible matches, and you can see then your human intelligence can say the first image is more closer, although you can say second is also matching, and you can say that query techniques. So there are 3 types of techniques in CBIR. This technique is called query technique. Second technique is semantic retrieval. There could be a possibility that you don't have a photo of that object, but you know how that object should look like. So you can have a drawing paint or any other pad. Nowadays we have touch pads. So you just take your paint, draw the object how it will look like, and search, and it will give you similar matching results. So that could be a semantic retrieval. Or it could be the combination of multiple methods, such as you have basically distance based matching, then color based matching, all other techniques, and then you say ki okay, this image was there in all the matching techniques, this image was in 3, this image was in 2, and so on. So image which is there in all the matching techniques is most probably that this is the matching image, and you can see it is actually. So multiple methods using, it's always better. It's like if you are checking something, it's even it is paper checking. You say ki you do the moderation, and those moderated papers will have better accuracy than the single check. Then you can say you check a reval paper, so that 3 level checking, and more the methods you will implement, better your result will be. Obviously slower will be your result, so that's why we need to implement a system which is faster as well as give you most accurate results. Now we were talking about features. Let's see what are those. So first feature is color. Now color of the object, most probably if you are looking for an object, the most prominent and easiest feature to see is the color of the image. Second is texture. So this is quite a complex thing. You can set 2 textures are same but not the color, and this is basically done using edge detection and nature of the edges, and whether they are horizontal, vertical, and how they are intercepting each other. And third is the simplest one, called the shape based technique. Here the transforms like hug transform, a line transform, or a vertical line measurement filter, horizontal line measurement filter, or other methods to detect other shapes are used. We go to the implementation of our project now. So the basic implementation has following steps. You give your input query image, you extract the features from the input query image, and you load the database. Read the images from the database one by one. Extract first feature from it. Let's say it's shape. If the shape is matching, no, go back, read the next image. If shape is matching, yes, then you come to the feature 2 extraction. Select the histogram. Check, is histogram is matching? No, go back, read the next image. Yes, histogram is also matching. So now we have compared shape matching, yes, histogram matching, yes. Then you will display the output image. Now if all the images are finished reading and matching, then you can go to the end location. Now same thing is explained in the algorithm fashion. So take an image from the database, extract its features, then load the images one by one, extract their features, compare with the different features like histogram, shape, texture, color, etc. and then finally present the images as in the ranked form. Now methods of CBIR. We'll stop here for some time.